Alright, hello everyone. The problem we're looking at today is the USACO 2024 February contest silver problem 1 of target practice 2. You can pause the video first and look at this problem yourself. The problem statement is pretty complicated. Alright, I assume you read the problem already. So this is a little bit more complicated than other problems in terms of the statement, and also just by those two lines up here, you can tell it's gonna be a pretty difficult problem. At least for silver, if you see those two lines, it's not gonna be easy. And so I'm just gonna use a drawing to illustrate what you're being asked. So basically you have several rectangles like this. And now all the cows are lying right now on the y-axis of this coordinate plane. You have a coordinate plane, you have rectangles on them, and all the cows are lying on the y-axis. But you don't know where exactly what y coordinate it is on the y-axis that they lie, but you know they have to be on the y-axis. And now each cow has a shooting angle, which means that they shoot at a certain slope. Every single cow shoot at a certain slope. It could be positive, it could be negative. And now for each cow, you're trying to assign it to a certain corner of these rectangles. And for the rectangle that you assign the corner, so say you assigned this cow this corner, then you had to move along the y-axis so that the slope aligns with this corner. So that means this cow shooting at its assigned slope can hit this assigned corner. And with one additional constraint, you can't shoot through this rectangle that you chose before hitting the target, which means you can't have this cow shoot this target because the slope is obviously positive, so you have to shoot through the rectangle before reaching that target. So that is illegal. You can't do that. You have to assign it to this corner or maybe this corner, right? And now you're trying to find the minimum distance between the uppermost cow and the lowermost cow. You're trying to minimize this distance between the y coordinate of the topmost cow and the bottommost cow. And now, given at most 4 times 10 to the 4th power rectangles and 4 end cows, you're trying to determine that minimum value between the highest and lowest cow. Okay, that's a pretty complicated problem, I would say, in terms of problem statement and in terms of solution. So now I can pause the video once again and maybe give this a try. Alright, I assume you tried this problem. So basically, the first thing that we notice for this problem is, like I already pointed out, you can't really have a cow with positive slope shoot one of these corners, right? One of these corners of these rectangles, because with positive slope, they have to shoot through the rectangle before hitting that corner. So now we know for all these non-left corner. Oh yeah, I missed out one condition. All the left endpoints of a rectangle have the same x value. All of them have the exact same x value. That's another constraint. And now we realize that for every single corner that doesn't have their x value lying on this x1, that's what the problem called it, x1, for every single one of these corners, we already know if it's going to be hit by a positive or negative slope. And for every single corners on the x1, like these that I marked out with the gray arrows, we can also determine who they're going to be shot with. Because think about it, if, say, after assigning all these non-x1 corners to cows with positive and negative slope, we have, say, M, these x1 corners marked with arrow. We have M of them left. Oh, that's a horrible M. M of them left. We can clearly see that we can just divide down the middle, and the lower ones are all going to be shot with negative slope, and the taller ones are all going to be shot with positive slope. And this is just pretty obvious, right? Because if you have positive slope shooting this one, it's obviously better than having that shoot this one, right? So you always divide down the middle, and the lower ones are shot by negative slope, and the taller ones are shot by positive slope. So now what we notice is that we actually have two subproblems here. We have two completely independent subproblems that does not interfere with each other, and we can solve them completely independently. We can just solve for the minimum y value for negative slope and the maximum y value for positive slope. So now how do we do that? Well, now we already know which targets are going to be shot by the positive and negative slope. We can actually just, for each target, we binary search the maximum slope. We can actually we binary search twice in this problem. First, for each subproblem, right, we binary search, say let's just use positive slope as an example. We binary search the lowest y value, and now for each corner that we know are going to be shot by positive slope, we binary search the maximum slope that we can have so that the y coordinate is still satisfies the mid. This is the mid y value that we just binary searched. So for this one, the slope is probably going to be like 0 point something. For this one, the slope is going to be like 1 or 2 maybe. And now we binary search that value for every single point that we know are going to be shot by positive slope, and we check if we have enough cows to satisfy all these constraints that we binary searched. This is kind of hard to understand because we binary searched twice, but here's look at my code to probably help. So first we sort all the left endpoints with their y coordinate, right? And then we know which ones are going to be shot by which type of slopes. And now, see, the two parts are completely independent. First, we binary search with positive slope. We binary search the maximum minimum position. The maximum minimum position mid right here. And now for this maximum minimum position, we go to every single point that we know are going to be shot by positive slope, which is found in this function. All right, check one, right? We for each of these number one points that we know are going to be shot by positive slope, we binary search the minimum value, the maximum slope that we can shoot it with. And we use a prefix sum array to count how many cows we need for each slope range. So I really strongly suggest looking at my codes, which will be posted in the comments below, because I have a lot of comments added in, and it'll just help you understand. So yeah, and also another fun thing about this problem is I still can't figure out why lower bound and upper bound didn't work for me. I had to like manually write a binary search. I used lower bound and upper bound, and I debugged for like hours and it didn't work. And I got so frustrated that I just hand wrote a binary search and it worked for no reasons at all. So I don't know, but here's basically how you solve this problem. It's kind of hard in terms of that. First of all, you have for silver. First of all, you have to notice that it's completely independent subproblems. No, actually, you first have to notice that you can divide it down the middle, and the lower ones are shot by negative slope, and the higher ones are shot by positive slope. And from that observation, leads you to the observation that you can divide it into completely independent problems. And finally, you can solve these problems using two binary searches. All right. Hopefully, after this video, you understand how to solve the USACO 2024 February contest Silver Problem 1 of Target Practice 2. Alright everyone, just like every other video in this series, now the problem review is done. We're on to the progress report time. So basically today I mocked the USACO December 2018 contest gold, and know that 2018, which is 6 years ago. So this is probably one of the oldest contests I mocked, and of course it's old and it's easy. So and also it's pretty late, so I could not finish this. I still have 30 minutes left, which I will be doing tomorrow. But today, within the 3 hours and 30 minutes, I solved this. I think I solved it using layered graph shortest path. I don't know if that's how you say in English, but it's an algorithm in Chinese at least. It's like basically dividing the graph into several layers. I solved it, but I don't know what book there is that cost me to not solve 9 and 10, which I will debug in the 30 minutes tomorrow. This problem traumatized me. This is way too much math for my brain. I think this is because the each cow only have five favorite flavors of ice cream, so it just made this problem a whole ton of math. Like it's so much combined thorax that I just hate this problem. And I wrote a brute force, but somehow it actually got way less points than expected. And the last one is really easy, actually, teamwork. I think I solved it before a while ago, but I don't remember anything from the last time I solved it, and it's still surprisingly easy this time. And actually, the time complexity is pretty high since my algorithm was NK, which is 10 to the 7th power, but still only 16 milliseconds. So I don't know. I don't know what's up with USACO today, because also for this. Oh wait, no. For the second problem, I tested and found that if you actually do n square for this compatibility problem, if you do n square, which is technically going to be time limit exceeded, you actually get all these wrong. Like I didn't come up with an n square solution, but I think it's gonna be pretty easy within the next 30 minutes tomorrow that I have to come up with an n square solution and just get all these points, which is kind of strange because. So basically, I wrote an n squared algorithm that does not do anything. It's just n squared. I just want to test whether it runs in the correct time, and it actually does. So yeah, that's interesting. So yeah, that's my progress today. I basically mocked this contest, this really, really easy contest that somehow still got stuck on one of the problems. And oh wait, no, this contest. And yeah, I did not study for nearly as long today, and actually the past 3 days as I would have expected. So yeah, lock in tomorrow.